Hello friends, we have stopped with that distance equation for inclined line of sight when the staff is held exactly vertical, and how to determine the R of or the elevation value of the point. If it is in angle of elevation, this has to be used, and if it is in depression, minus V minus R. In somewhere in any other book they may use, instead of R they may use H, and instead of H they may use some other staff value, right? So but the concept you have to remember, right? So we will see with the problem. A leveling staff is held vertical at distances of 100 meter and 300 meter from the axis of a tachyometer, and the staff intercept for horizontal sides are 0.99 meter and 3 meter respectively. There are two positions. So for the two positions the staff intercept were given. Based on that we have to determine the constant for the instrument, and that constant, what are the constant? Multiplying constant and the additive constant, that is K and C, that has to be applied to the remaining condition. Next, the instrument is set up at a station A and the staff is held vertical at a point B with the telescope inclined at an angle of depression. It is not elevation, it is depression of 10 degree to the horizontal. The readings on the staffs are 2.670, 1.835 and 1.000. From this you have to judge which is the top reading, which is the middle reading, which is the bottom. Obviously the top reading will be higher value, mid, and the bottom will be lower. So here it is top, middle, bottom. Calculate the R of the B and its horizontal distance from A to B. The height of instrument is 1.42 meter and the R of station A itself is 450.5 meter. Right, now two tasks. First you have to determine the constant and then you have to determine the R of the station and the distance, right? So better you try to visualize and draw the diagram. For the first condition, say the instrument is set up in the terrain and the staff is held exactly vertical and the horizontal line of sight is maintained, and at 100 meter staff was held and the staff reading was taken and its intercept is given as 0.99 meter, and at 300 meter distance the same line of rays makes a staff intercept 3 meter, right? So now we are having the detail. It is to determine the constant, right? So solution, you know, D is equal to Ks plus C. Here we are having two distances, so D1 is equal to 100, D2 is equal to 300, and S1 is equal to 0.99 and S2 3 meter. Substitute all this thing, you will get a two equations. From the above equation you are able to get the value of K by solving both the equations. K is equal to 99.50, right? If you substitute that K value in any one of the equation, you are able to obtain the value of C. Here we have obtained the value of C as 1.5 meter, right? Next they have given the instrument is set up at a station A and side to the staff held vertical, exactly vertical over the station B, and it was viewed in the angle of depression from the line of sight. So the center ray is the exact angle measuring point. So from the line of sight to the center ray it is 10 degree angle of depression, and it was given the staff reading is 3 staff reading, top, middle, bottom. Here we have noted down, and the R of the station was given and the height of instrument was given. The task is the distance, horizontal distance between A and B has to be determined, and the R of B, right? R of B, how we can determine? R of B is equal to R of A plus height of instrument 1.42. It goes up to this. From here to the center reading is considered as capital V, the vertical difference. From this center to the ground is we denoted as R, or it may be given as H also, right? So RL plus height minus V minus RRH, that gives the RL of B. So these are the tasks we have to determine, and for the horizontal distance you are having the formula D is equal to Ks cos square theta plus C cos theta. Similarly, for determining the V, we are having the formula Ks sin 2 theta by 2 plus C sin theta, right? That these formulas has to be utilized, right? Similarly, now top minus bottom give the staff intercept 1.600 and theta is 10 degree. The horizontal distance equation for the inclined line of sight is D Ks cos square theta plus C cos theta. So substitute, we are having K value and C value, S value you have determined, and theta you are having. Substitute, you will get the distance 162.63 meter. And the vertical distance V is equal to Ks sin 2 theta by 2 plus C sin theta. Substitute all the values, you are able to get 28.67 meter, right? So then RL of B is equal to, I have explained already, RL of A plus height of instrument minus V minus H. Here the H is 1.835 and V we have calculated here, and height of instrument is given as 1.42, RL of A is given. If you substitute all the values, you will get the RL of B. That is the task. So you try to visualize the problem and try to draw, and it is very easy to solve it, right? I hope you understand, friends, right? Thank you. I will give a task for your attendance, right? Thank you.